So I'll just outline what I'm going to cover in the presentation. I'll start with an introduction. I'll then briefly discuss the local geology, historical mining and previous work. I'll then describe our most recent observations from the Perseverance deposit and what they might mean for mineralisation. Then I'll cover the regional scale GCAS data for Region 9A, which covers the Tarcoola area. We'll then zoom into the Tarcoola goldfield and look at how this new data could potentially influence exploration. And then just some key findings at the end. So the Tarcoola goldfield is located in the northern part of the central Gawler gold province. It also coincides with the junction of the Trans-Australian and Adelaide to Darwin railway lines. Alluvial gold was first discovered in 1893 by Brown, which then led to the discovery of vein-hosted gold in 1900, and underground mining commenced in 1901. Mining exploration has continued intermittently since the 1900s, with the most recent mining being undertaken by WPG Resources, and that's at the Perseverance deposit. And this open cut mining by WPG has provided a great opportunity for the GSSA to collaborate with the company and undertake detailed structural mapping to investigate the key controls on mineralisation at Tarcoola, and hopefully to expand these to a regional scale. So the stratigraphy of the Tarcoola goldfield has long been established by previous workers. There's the Paxton granite, which is mostly a Monza granite with lesser cyanogranite and quartz monzonite phases, and it's been dated at 17-15 million years. The fluvial to marine Tarcoola formation has been interpreted as non-conformably overlying the Paxton granite. It's been subdivided by Daly into three members, the basal peeler conglomerate member, and the Fabian quartzite and Sullivan shale members. And both the Paxton granite and Tarcoola formation have been intruded by dikes of the Lady Jane diorite, which is part of the Gawler Ranges hill to river band. Previous mapping has locally identified east-northeast trending, shallow west plunging, open upright folds. Several styles of faulting have been observed in the area. Firstly, large-scale south-southeast open north-northwest directed thrust faults that have developed in Paxton granite. And these were attributed to earlier stages of regional north-northwest, south-southeast compression. There's north-northeast trending faults and a northeast-northwest trending conjugate fault set. Bedding parallel thrusts were identified and documented in underground workings, where they were interpreted to represent late-stage compression. Alteration and mineralisation is controlled by north-northeast and northwest-oriented faults. It's generally hosted by quartz veins that cross-cut the Tarcoola formation and Paxton granite. At the Perseverance deposit, which is located there, the north-northeast trending Perseverance fault is interpreted to have played a major role in focusing mineralisation. And it's long been recognised that alteration of mineralisation is coeval with the intrusion of the Lady Jane diorite. I'll now move on to the work that we've been doing with WPG in the Perseverance open cut. So our new work is largely consistent with previous observations. Bedding strikes east-northeast with a moderate dip to the south. One difference is that at the pit scale, the non-conformable contact between the Paxton granite and the Tarcoola formation has been reactivated and is overprinted by thrust faulting due to south over north shortening. Our new work also identified several orientations of faults. The earliest are the east-northeast trending, south-dipping bedding parallel thrusts, which is different to previous authors. There's a series of northwest trending, steeply south-dipping reverse faults, and the northwest-northeast trending conjugate fault set. Perseverance Fault forms a major feature of the deposit. The fault trends north-northeast with steep westerly dip. It varies from 1 to 5 metres wide with anastomosing margins. Displacement is predominantly sinistral strike slip, and it offsets the granite sediment contact. Our new work shows the dikes of the Lady Jane diorite are typically northwest trending with steep to subvertical dips. They display various relationships with the fault. This northwest trending dike cross-cuts a bedding parallel thrust, it's offset, and then is cross-cut by another bedding parallel thrust. In other locations, the dikes coincide with northwest trending faults, reverse faults, and they've been offset. North trending dikes are also observed in the floor of the pit, and they are parallel to the Perseverance Fault. We observed two main styles of mineralisation in the deposit, disseminated and vein-hosted. Disseminated mineralisation occurs along fractures in the Paxton granite, along bedding parallel fractures and northwest trending fractures in the Tarcoola Formation, and along the contacts with the dikes. It also occurs within fault-bounded blocks within the Perseverance Fault. Vein-hosted mineralisation is predominantly associated with quartz veins that occur along the sheared margins of the dikes, and minor sulphide-only veins also occur both within the sediments and along dike margins. So these new observations suggest progressive north-northwest, south-southeast directed shortening, which initially resulted in shearing along non-conformable contact between the Tarcoola Formation and the Paxton granite. At this stage, the Paxton granite may have acted as a relatively rigid body during deformation. Continued shortening resulted in bedding parallel thrusting, the steeper reverse faults and the conjugate fault set. The Perseverance Fault developed relatively late in the deformation history with a switch to strike slip displacement, which has probably occurred once all the other fault sets have taken up the majority of the strain. Emplacement of the Lady Jane diorite was contemporaneous with bedding parallel thrusting, northwest reverse faulting and the Perseverance Fault, and provides an age constraint on deformation. So that history has implications for mineralisation in the Perseverance deposit. First, mineralisation is focused along geological contrasts at reactivated boundaries that occur between the different lithologies and along suitably oriented structures. Second, mineralisation is focused at sites where these boundaries and structures intersect the Perseverance Fault. And thirdly, if the Perseverance Fault controlled fluid flow, it would imply that mineralisation occurred relatively late in the deformation history. I'll just briefly zoom out to a regional scale. As part of the project, we were able to access the new geophysical data for Region 9A that covers the Tarcoola area. And the Region 9A data was released on Monday of this week. This led to an updated and more detailed solid geology interpretation, which you can see on the right. So if you look at the reduced to pole first vertical derivative image, you're able to distinguish quite a lot of detail in the fault networks throughout the area. In particular, the north-northeast trending basement fault that was identified by Daly is quite clearly visible, but with the new data, we've been able to demonstrate that it's much more extensive. If we zoom into the Tarcoola area, the Tarcoola Formation is characterised by that magnetically bland signature, and this area has been interpreted as Paxton granite. You can see that the basement fault is about 25 kilometres long, and it has a substantial northerly trending section. In a north-south compressional regime, this section of the fault would be under dilation. The new data also highlights another north-northeastern trending fault, approximately 3 kilometres further east, which is also interpreted to cross-cut the boundary between the Tarcoola Formation and the Paxton granite. The intense magnetic high is due to the Geological jasperite, and this locally occurs as clast in the basal peeler conglomerate member in the Tarcoola Formation. So if we zoom into the Tarcoola goldfield itself, you can see those linear magnetic highs, which are presumably a result of the Geological and jasperite clasts within the Pawley conglomerate. The basement fault and the other north-northeast trending fault are highlighted, and the green dots are mineral occurrences available from Surrey. Perseverance deposit's located here, and you can make out a sinistral offset in the conglomerate which is consistent with the Perseverance fault. Looking at the data, is this another area, another fault offsetting the Tarcoola Formation, and therefore an area of potential mineralisation? Similarly, are these also areas that could be potential targets? If we overlay the gold and calcrete values available from Surrey, you can see an interesting correlation with the Pawley conglomerate and also with the basement fault at the southern end. So just to highlight the key findings, at the Perseverance deposit, geological contrasts, ongoing deformation, development of northeast and northwest trending conjugate faults, dike emplacement and north-northeast trending faulting are key ingredients controlling mineralisation. Mineralisation is focused at sites where these favourably oriented structures and lithologies intersect the north-northeast trending Perseverance fault, and it's occurred relatively late in the deformation history. These processes leading to mineralisation in the Perseverance deposit are not that dissimilar to processes occurring in the orogenic deposits of the Victorian goldfields. Preliminary interpretations of the GCAS data have highlighted additional north-northeast trending structures that cross-cut the Paxton Granite Tarcoola Formation boundary, which is similar to the basement fault and the Perseverance fault occurring in areas of known mineralisation. And the new geophysical data with the spatial resolution available and the improved accuracy has the potential to dramatically improve exploration targeting. The authors finally would like to thank WPG Resources for access and the opportunity to work with them, in particular Paul Whitwer and Sarah Traeger for all of their assistance. Thank you.